Hey guys, welcome back to my math channel, and today we are continuing our discussion on exact equations, and I will actually be continuing the example I started in my last video, so the introduction to exact equations, and today we'll be actually solving the exact equation because last time we just determined how to find whether an equation was exact or not. So continuing on to that problem, I'm going to go down here, and we have the problem from last time. And if you remember from last time, we determined that this was an exact equation because if we take this equation and put it in the form of mxy plus nxy y prime equals 0, where y prime equals dy dx, we just divided this equation by dx and got 3x squared minus 2xy plus 2 plus 6y squared minus x squared plus 3 y prime equals 0, and that's in this form right here. And when we take the derivative of m in terms of y, we get negative 2x, and the derivative of n in terms of x equals negative 2x as well, and we see that these two are equal, so that in turn means it is exact. So that was just my really quick reiteration of showing that this equation is exact. So now that we know it is exact, we also know another important fact that will help us determine the solution of this equation. So I'll go down. So we also know, because this is an exact equation, and we know that m equals the derivative of some function f in respect to x, and we know that n is the derivative of some function f respect to y, where f of x, y will be our solution. So using this information, we can find f of x, y, which in the end will give us our answer. So using that information, let's go down and write that out. So we have m equals fx and n equals fy. And that means fx equals fy equals, I'm just going to set that up and then need to. So I went back up and copied down m and n, which, if you want to remember, is this is m and this is n. So I just copied these down here, and now we can solve for f, x, y. The way to do that is just to integrate each of these, and it's just kind of like a series of integration in derivatives. Once you do multiple of these problems, you'll get the hang of it. But first, you want to take the integral of fx in terms of x, and you end up getting f equals x cubed minus x squared y plus 2x. And you also want to have some function g of y. This is because when you take the derivative of g of y in terms of x, so going the opposite direction, you end up with 0. So we need to have this arbitrary y function right here to balance things out. So now that we have f, we need to solve for this g of y. And to do that is to take the derivative of f in terms of y and set it equal to this thing, to the left-hand side. And that will help us find this arbitrary y function that we have here. So if we take the derivative of this in terms of y, we end up getting 0 for this term, and we end up getting negative x squared for this term, and we get 0 for that term, and we get g prime. So now we can see that if we set these equal to each other, we see that g prime of y equals 6y squared plus 3. And if you integrate this, you end up getting g of y equals 2y cubed plus 3y plus c. So now that we know our g of y, we can plug it into this and finally get, or oops, I just scrolled all the way up there. Finally get our full f of y, f of x, y function. So let's write that out, and we end up getting x cubed minus x squared y plus 2x plus g of y, which is plus 2y cubed plus 3y plus c. And so our solution will be x cubed minus x squared y plus 2x plus 2y cubed plus 3y equals c. And that is our final answer. That is our solution to the exact equation.